Every year, the Mars City Design Group hosts a design challenge where students, architects, engineers, and designers can all come together to design some really cool new buildings and landscapes specifically for Mars. Last year's challenge was urban farming, and the winners were announced earlier this year. So today, we're going to take a look at the top 5 entries. I'm Sarah Gilbreath, and this is the Martian Street Food Society. The Mars City Design Group specializes in Marschitecture, or architecture specifically for Mars. This last competition challenged participants to create a system of urban farming that could be used by colonists sustainably going forward. First up is Justin's Mars Farm. Now, the creator of this plan is actually a thermal systems fluid engineer in the commercial aerospace industry. No surprise then that Justin won in the engineering category. What's really interesting about this design is the way it's broken into 5 different modules. Now, in the explanation video, Justin says that this is to increase fault tolerance, so it can set along different fault lines without being disrupted. But to me, the coolest thing about this project isn't the design itself, it's the code that comes with it. He's actually built out full mathematical models in MacLeod to predict the amount of sunlight the plants will get at any given point throughout the year, taking into account things like vernal equinoxes or even the planet's albedo. His entry also includes full thermal modeling, which allows him to pretty accurately predict the internal temperature of each one of those greenhouses. He also makes the pretty convincing point that using these kinds of closed farming cycles would also dramatically increase our yield here on Earth. We wouldn't be beholden to seasonal cycles or climate, we wouldn't need to rely as heavily on pesticides or herbicides, and we could dramatically decrease the amount of water we use, he says, by as much as 90%. Number 2, the Mars Spine, winner in the design category. This design was inspired by a lily pad and features structural ribs that flow outward from a central point, just like veins in a lily's leaf. It's also made using 3D printing with Martian regolith, similar to earthbag building here on this planet. That means that we wouldn't have to transport quite so many materials for building. We could just use the dirt that's already there. The design is divided in 2 right down the spine of the leaf and is covered with fiberglass to reduce friction from the sand that can be kicked up during those Martian storms. Now, most of this design is underground, but there is one part that pretty significantly juts up out into the sky. That's the part for the astronauts' recreational area. Now, in addition to the pads array, which is the section that uses the more traditional farming techniques, there are 2 other kinds of techniques at work here: hydroponics and aquaponics. That means that this design will include the use of fish. And I personally love that they have this much water in it, given that the design is a lily pad. And that hydroponic system means that they don't need soil for that entire section of the farm, which removes the need to filter out the perchlorates. Also middling in the design category was Barkan City, and let's be honest, this is what we all want Mars to look like. It's so cool, right? Like, look at the design of this. The graceful arc, the gentle slopes, the weird forms. I love it. It's a great design. This design takes into account the lower gravity on Mars and makes the best possible use of it, because the lower gravity means that we can have taller and wider buildings with less structural support. So this one says, let's do it. Now, unlike some of the other projects we've seen today, this one is based on aeroponics, at least to start. That's because aeroponics requires fewer resources and is also more compact, meaning you can fit more crops in a smaller area. Next up, Sprout, the winning design in the Marschitecture category. And personally, I don't think this looks like a sprout, I think it looks like a snowflake. What I love most about this design is the way that it starts small right in the center and then gradually builds out in stages. First, a number of robots running on AI will land near the delta and set up a number of different power collection systems, including things like solar panels, as well as batteries to store it all in. Once they've got the power systems in place, the robots will begin forming bricks out of the material they find in the delta, and they'll use that to start building algae pools around a single photosynthetic collector core in the middle. This design features 3 different systems: photobioreactors from the sun, organic bioreactors from the algae pools, and organic carbon engines. Now together, all 3 of these will work to produce energy and soil amendments, which are changes that we need to make, like fertilizer. Now, all of that is just for the center core, or the green powerhouse. Once that is built, the arms will extend further out to include space for farming. He's got seed banks, he's got insect processing areas, and one of the really cool things is that most of the work for this design happens before the astronauts even get there, including growing some of the plants. Now, while all of these designs were created to support the astronauts, they don't all seem human-centric. In fact, one of them didn't even require people to be there for it to be built or for it to run. But the next design we're going to talk about focuses primarily on the astronauts first. This is Mars Colony 1, the second place winner in the engineering category. You can see that it's stacked up vertically, and in a lot of ways it's designed kind of like a lighthouse, with each separate section having a different distinct function. Now, the previous designs based their crop selection on things like nutrients and dietary need, but this one brings in another aspect: menu fatigue. If the colonists are bored of eating the same food over and over again, they probably will stop eating it, and that's not going to be healthy for them. Also, look at where the actual growing model is relative to the rest of the structure. It's not just right on the ground or even underground like so many of the other ones are. And this actually gave me a new idea that I hadn't thought of before, which is if you had your crops relatively high up, you could have sunlight coming in at any different angle. And I don't think I've ever seen a farm that had sunlight or any kind of light being applied to the bottom of the plant or the side of the plant. Even in situations where we're completely creating the farm from scratch, most people tend to put the plant on the bottom and the light on the top. Do we need to do that? Does that actually benefit anything? I don't know, and I love that this design makes me think of that question. The crops they chose go beyond the standard vegetables, fruits, and fish that the other projects covered, and include things like soybeans, which is a major crop, that they then use to make into soy cheeses. They also say that they will be importing all of their wheat in order to minimize explosions, which, what?
We plan to bring wheat flour already processed to avoid danger of explosion.
I don't know what that means. Does wheat explode in Mars? I've never seen that, but now I just really need to interview this team. Side note, I did some extra research after filming that last portion, and it turns out, yes, flour is extremely dangerous to produce because it can explode. In fact, between 1994 and 2003, there were over 115 explosions in flour-producing plants here in the US alone. Now, a lot of this is because of the amount of flour particles that are in the air during production. And because of the lower gravity on Mars, that factor is going to be even higher, meaning it'll be even more dangerous. I'll do another video sometime down the line with some more details about this process. They're also going to bring in some different flavor palettes by incorporating bacteria, which allows them to create fermented foods like cheeses, soy sauces, and even sauerkraut. They even included a menu with pictures of food that they could grow in this system. Martian burgers and smoothies, that's exactly what I want in my design challenges. So what are our takeaways? Well, one, for some of these, it looks like humans won't even need to be present at the early stages of building these farms and habitat structures. And two, if we look outside the traditional farming models, there are a ton of different options for farming that avoid all of the soil problems we've talked about before on this channel. Things like aquaponics or hydroponics or aeroponics use little to no soil, so they just sort of neatly sidestep that problem. So my question to you guys, which of these designs did you think was the most interesting? Or if you had followed along with this challenge, were there any other entries that you thought were really cool that you wish I had talked about? Thank you so much for watching. See you next time.